Differential equations, we're taking a look at the 4.1 through 4.3 review. And the second question is actually related to reduction of order, not using the formula that we've talked about. We'll see that on our next problem. What these problems generally do, however, is they will give you that you have one solution. You can see we've got a second order differential equation here. They're actually nice. They tell you the first solution is x to the fourth. They want you to find a second solution. And I've given you a little hint here. For that second problem that we're going to be looking at, we need to get some practice on assuming that y is equal to some other function of x. We'll call it u times x to the fourth. So let's get started with that right now. If we had that, we can then say, well, y prime is going to be with the product rule. We're going to say that's u times a 4x to the third. And then we could say plus u prime x to the fourth. So in other words, we will have a 4 out in front here. And here we'll just have our u prime x to the fourth. What we're going to do next, however, is we're going to take this derivative that we just had here, and we're going to go ahead and take our next derivative because we're going to be substituting this in. And now we're going to have to do two product rules. You can see that y prime, as we take a look right here, that's going to be 4u times this 3x squared. That's our derivative of the first part. But then we'll have a 4u prime times x to the third. Now it's at this point that we also have to be aware that there's also this other part that we have to use the product rule on. The derivative of u prime is u double prime. And then we could say, well, we'll have our u prime times the derivative of x to the fourth. That's going to be a 4x cubed. Well, as we clean this up, I think you can see 4 times 3 is a 12. We'll have a 12ux squared. Here we'll have a 4u prime x cubed. And by the way, here's another 4u prime x cubed. We'll see that in just a moment too, right? You know, at the end here, you can say, now wait a minute, these are like terms. So I'm going to clean this up a little bit. I'm going to actually have my highest derivative, a u double prime, coming first. That's this term right here. The 4u prime x cubed, there are two of those. 4 and 4 add up to 8. We can write that a little more easily right here. And then, of course, we also have our 12u x squared. So that right there is working out rather nicely. And I guess what I just want to show you is we have our y, we've got our y prime, we've got our y double prime. And I'm going to just come real quickly and say, you know what? Let's just recopy that differential equation right here and plug those in. When we plug in that y double prime, of course, we'll have u double prime x to the fourth plus an 8u prime x to the third plus a 12u x squared. Then we'll say a minus 7x. Well, what about our y prime? Well, that's this thing in yellow right there in the middle. 4u x to the third plus a u prime x to the fourth. And then finally, we'll have our 16 times y, but our y is really this u x to the fourth. So we've got this all together right here. Let's see if we could clean this up a little bit and see where we're going. You know, obviously, we're going to distribute, and we'll have a u double prime x to the 6. Here we'll have an 8u prime x to the 5th. Here we'll have a 12 u x to the fourth. Here I'm going to distribute a negative 7. Negative 7 times 4 is a negative 28. And then we'll have our u and x to the fourth here. We'll have a minus 7 u prime x to the fifth. And finally, we've got our 16u x to the fourth. Well, hopefully we can see that this is cleaning up. Let's put our like terms together. We're going to have a u double prime x to the sixth, but let's start looking at just what we have for our u single prime. We've got this 8u prime x to the fifth. We have a minus 7u prime x to the fifth. That's going to add up. 8 minus 7 is just going to be a 1. So we'll have a 1 u prime x to the fifth. And then what? Well, if you look at your 12u x to the fourth and a 16u x to the fourth, that adds up to 28u x to the fourth. That's going to cancel right here, and that's delightful. All of a sudden, this really messy looking problem has just gotten way, way, way nicer. Tell you what, I'm going to just divide everything by x to the sixth. This is what we mean when we are going to have reduction of order. This is going to become so much nicer. We've got u double prime plus, well, this x to the fifth over x to the sixth, we could write that as just 1 over x. And hey, things are looking up. They really are. Let's off to the side just make mention of something. Right now we're going to let w equal u prime, and then w prime would equal u double prime. And the reason why we do this, we actually did this in the past units that we've worked with, is now, thank goodness, as you're looking at this, this becomes a problem that we have solved before with an integrating factor. The integrating factor, you might remember, is this 1 over x right here, and we're going to say, look, our integrating factor, we're going to say that's e to the integral of 1 over x dx. That's e to the ln of x. Ignore a constant. And all of a sudden you'd say, well, wait a minute, that's just going to be an x. What do we do with an integrating factor? Well, we multiply every part of the problem by it. Even over here, that's x times 0. And where are we going? Well, you can see here's x w prime plus just a w is equal to 0. Now, the whole purpose of having the integrating factor is so that on the left side, you can see this as a product rule. Hopefully, as you're looking at that, you can now see this really as x times w, and we're taking the derivative of that. Remember, we've done that so many times in the past. That's really from the product rule. And we're getting a tremendous hint right here. You know, the product rule is one function times the derivative of the other. That's your x times w prime. And sure enough, if you double check that, you're going to see you're good to go. Well, once you see this as an integrating factor, then you can integrate both sides with respect to x. This will leave you with an xw. The antiderivative of 0 is just some constant. We could write it like that. And tell you what, right now this w, we could say is really some constant all over x. But w, please remember, is really u prime. So I'm going to continue right over here. If u prime is some constant divided by x, guess what? We can right now just take an antiderivative on both sides. And we'd say, well, what would we get? We'd get our u. How about right here? We'd say, well, the antiderivative of some constant all over x, it's some constant times the natural log of the absolute value of x plus some other constant. We're almost done. We are so very, very close. This is your general solution for u. We could say, let's let c1 equal 1. Let's let c2 equal 0. And that would mean that u would be the natural log of x. Now, at this point, what we can do is actually come back to this start, that y is equal to u times x to the fourth. That was our assumption. And our u was actually the natural log of x times x to the fourth. This is our second solution. So that's how you do a problem like number 2.